Hello everyone. Our next talk is called DevLI, 0 Days Full by Ali. Stage is yours. Thank you.
Hello everyone. How's your energy today? It's the first time here at BalCCon conference and first day as well. I hope you enjoyed the conference so far. And today, today I'm gonna talk about application security stuff like DevLI, 0 Day Full. It's mostly about the RASP. All about my experiences. So all the experiments that I had within a year, like testing different kind of RASP solutions, runtime application, self-protection, and then, I'm waiting for the slides. No worries. All right. Here we go. So, before everything, so a little bit about myself. So I'm Ali. So I've been to the industry for almost 12 years. So currently I'm application security lead at Canon. So you all know that company. So I'm also author. So my book will be published by Wiley in a couple of months. One of the best guy in the field as well is here today. So I'm also a reviewer at Elsevier, Springer, and previously Hacking 9 magazines. And I really believe into that the principle of sharing is caring. It does matter, So, and this is why I always participate in security events, conferences, and I always participate yearly for 2-4 times a year, and this one I think is 29 or 30 conferences I've been as a speaker or trainer, and I really love that one, socializing with you guys, finding experts in different fields, that's really nice. And also, I'm a lifelong learner, so I always think that, once you going deep into a field, a deep dive into different topics, so you will understand that you know nothing. So that's why I think that I'm always learning, and I'm calling myself a lifelong learner. Let's start with this presentation. So a little bit more about this presentation itself. So this presentation is going to be a boring one. Why? Because this first section, I'm going to reviewing the principles and fundamentals of application security, and for most of you, I think that one will be a little bit boring. So, however, the second section will be a little bit interesting. Why? This time, because I'm going to share my practical experience with you guys, just to share that knowledge, just what happened during different experiments, during different setups, and the comparisons, and also the technical and non-technical strategic difficulties which I had. Yes, we have a question? Okay, sound problem, this one? Is this better? Okay. Then, all right. So the first section will be a little bit boring, but the second section, so I hope that will be enough interesting for you guys. So if you're started, let's dig into. So my first question is always that what is the difference between software security and application security? And so many folks say that they're the same thing, but I just wanted to have some argues there that I think that the software security focusing more on the full development lifecycle, beginning from 0 to 100%. And also it's also including the activities within the pre-deployment, all the practices there, like the design, security by design, and the secure software development lifecycle, et cetera, et cetera. All of those are related to post-deployment as well. However, I think that application security is more into post-deployment, all the activities after you release the application, all the caring regarding your source code, regarding the application itself. If it is a web application, you will perform PT, you will perform vulnerability assessment, etc., etc. Then I think that the software security has a broader level of coverage, and application security can be a child process of software security. And when we have secure software development lifecycle, then we can include AppSec as well, and also the related processes. So I think that the ecosystem can be something like this. We have secure software development lifecycle, which is including all the things, and one of the necessary things is the secure by design, all the related practices to once you're starting the architecting, so you have the secure architecture review, and you have the infrastructure as well. So you will review all of those, and also you will review all the dependencies, all the libraries going to use, all the necessary third-party tooling, and all of those. And those are also including in secure by design, and secure by design is a big part of software security development lifecycle. Sorry, secure software development lifecycle. And also we have static analysis and dynamic analysis as a part of the process. It can be also, we can put it into the SSDLC as well, and so many other things that I'm going to cover within this presentation. So let's talk about the AppSec ecosystem. So first, we've heard about a shifting left, and this terminology so many times, thousands of times within last 10 years. So it's simple. So it's just going to focusing on moving all the security practices, all the security testing into the development phase, into the earliest stages. Instead of spending thousands of dollars and euros to performing penetration testing and finding the vulnerabilities and dealing with mitigation. That's a bad part of our job, actually dealing with other departments and developers and other third parties. So it's better to move and shift those practices into earlier stages, like from the planning, from the code. So you can put code review there, so you can have the static analysis, or you can do it manually or automated. Then I will also cover that one, and also testing during the development as well. So that's a principle of shifting left, and also it does matter. It's so important, and that's a part of the AppSec ecosystem nowadays. Then we have to consider continuous improvement, and continuous improvement, I think one of the items here is vulnerability management systems results. So most of us in the companies, organizations, they have VMS. They have different solutions. They have even dedicated departments and engineers for to handling and operating the VMS. But the necessary part of the vulnerability management system is the result of the vulnerability management system. Oh God, I have a dashboard here, and it's showing me thousands of findings within my colleagues and employees' assets, and how can I deal with that? So the most important part is how we are going to address those findings. So what is my plan? How am I going to address all of those? How can I get rid of those vulnerabilities? So it comes within prioritizing the findings. It comes with a strategic planning, and also collaboration with other teams and departments. And then also regarding the continuous improvement, we have hardening, which is, I think that I believe that hardening can happen 2 times at least. So one can be once you want to mitigate something, then you can move with the hardening. You can harden your asset, and then also you can bring hardening into early stages once you want to perform a baseline, preparing the baseline security. And there are lots of and hundreds of standards and frameworks like NIST, like ASVS by OS, but MASVS if you have mobile applications. So you can use a hardening guidelines at least to prepare a baseline for your assets, and even for the development phases. And then we have yearly penetration tests and yearly security assessment, which is sometimes companies really like to put these 2 different operations together, but in fact, these are separated operations. It should be segregated. So security assessment focusing on something else depending on the type of asset and the technology and or the whole tech stack. Also penetration testing outcomes can be a kind of complementary one after security assessment or before that. So yeah, that's important. And then I discussed about security testing. Let's open it up. So we have automated option and manual option of security testing. So for automated, we have like different SaaS solutions. So there are also cheap solutions and also expensive solutions, and even you can use open source solutions if you want. So not sure about the reliability of those, but that's an option. And then we have IaaS for interactive application security testing, and also software composition analysis kind of activities. And then question marks, that's what I'm going to cover in the second part of this presentation. So, and for manual testing, so we can have code review, manually review the code, and also penetration testing, or even red teaming, we can put it here for the security test. But also, yeah, tests is everywhere. And then regarding the software composition analysis, so we must consider SBOM as a huge inventory of all the dependencies, libraries, etc. And also the SCA will cover the scanning all of our open source components depending on the policy, and also the configuration and the strategic policies are super important in this phase. Yeah, is there any other factor? Yes. It's not really technical, but yeah, I really like this picture. So yeah, security training and security awareness is a requirement of every kind of testing and every kind of security policies. So it's super important, even if you have a big fortress of security solutions, top products, and really nice pen test results and nice red team, blue teaming. But if you have a nice colleague that's clicking on something suspicious, then he or she can ruin all the things of, and that's super important. Just having security training and security awareness at least once or twice a year. So as a part of a workshop or as a part of a kind of interactive demo, something like that, for better awareness. And yeah, let's talk about the tooling disadvantage. So I think that security tooling, they are not that cheap. Many times they are super expensive, and also if you are not on a very good budget, so you must consider to choose the best one which is working for you. Also, that's a trade-off between the cost and the technical capabilities. So that's super important. So, and also most of the tools, they are limited to some predefined and patterns and signatures. So within their databases, not all of them, but yeah, most of them actually. I'm not gonna open this up, but yeah, and most of us say that we have thousands of findings within the DAST or SAS dashboard. So, and in many cases, I've seen that there are lots of false positives there. Then you have to actually verify all the findings. You have to verify if this is a correct one, or if this is a false positive or false negative, your findings. That's super important, and it also costs money because it costs time. It requires times to perform those verifications, verifying if that vulnerability is valid or not. And AI, oh God, so we're hearing about AI. Yeah, it's a lifesaver, but that sometimes it's just a fancy bottom, or it's just a fancy word within the data sheets. I don't know, but if you have a nice experience dealing with AI-based or AI-powered solution, just let me know. So I would be super happy to work on that, because it was always AI, but I've never seen AI in action, It's just a marketing kind of word or terminology. But I hope it can be better in future. And the integration difficulties. Yes, you have DAST, then you have to deploy it in somewhere which is actually accessible for your tenants, for your applications, for all of your targets, and also it's the same as SCA and IaaS as well. Like IaaS, in most cases, it requires high performance, and you must allocate a a number of CPUs and RAM to perform IS testing as well. So integration sometimes is difficult. But is that fair enough? So tooling, awareness, training, and strategies secured by design, all of these, is that fair enough? Definitely no, that's not enough. So static analysis, dynamic analysis, and interactive application security testing, they have some limitations. So yeah, limitations. Let's talk about starting with SaaS. Yeah, SaaS limitations. So within SaaS, so it's a little bit hard to find the runtime and environmental vulnerabilities, obviously, because it's going to be perform scanning on the code itself and or a code base, depending on your policies. And also covering the modern attack vectors like API security checks. Sometimes it's a little bit hard to find a SaaS solution, which also you can put the YAML configuration there. So there you have to buy another API security platform to be able to analyze your YAML files and also all the codes within your APIs. And also, again, a high number of false positives and false negatives. And it's actually the false positive is the noise, and false negative is the lack of detection is coming from the technical standpoint. So it means that if you see a false negative somewhere in the dashboard, it means that the finding is totally invalid. And then also false positive can be sometimes the occurrence of a vulnerability that the engine couldn't detect that it found before on one of the assets or one of the targets. And regarding the scalability and performance issue, so I had some issues before within the large code bases and also incremental scanning that sucks actually within most of the SaaS solutions, but also some DAST and IS solutions, they provide such a nice incremental scanning. All right, so let's talk about DAST. So yeah, manual verification is a must. So once you have a result of a web application, a DAST report on a web application, you must perform a manual verification. So you can't rely on the report, even if they provide a really nice report. But also it requires time to configure all of those and also put the required best practice or regulation there. And also most of the DAST solution, they're working based on a database. So if they find that this pattern or this pattern with the database, they say this is a SQLi. And this is the, if they find any kind of, a scripting response or JavaScript there, they think, okay, this is a cross-site scripting tag. But no, this is not a cross-site scripting tag because they can't verify that. So sometimes DAST solutions, they have, so if you right-click on the findings, then you can reproduce it or to verify the findings. But also it requires time and effort, the technical effort. So you have to do it on your own. So, and yeah, business logic, you can't rely on DAST solutions if you want to find business logic. So business logic vulnerability is often finding during the penetration testing or red teaming. So it's also very important nowadays, mostly for financial application and sensitive companies and targets. And also false positive, 100% like SaaS. And then, we are going to cover the IS limitations. Three main limitations for IS. So I can say that the dependencies is the most important dependency is the real traffic. And because you must provide the real traffic and also enough traffic of your target or your assets to be able to expect a complete report and finding the expected vulnerabilities. So IS relies on real traffic, so you must be able to configure all of those and trying to sometimes redirect the traffic, the real one, to your IS setup, to your IS engine, I would say. And also the cost issue, that's super expensive sometimes because so you have to buy the license and also you have to pay for the maintenance as well and somewhere to run the IS and also connect and integrate the applications within your IS engine as well. But also it depends on your architecture. The third one can be the performance overhead, which is 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 always introduce new overhead, and it requires quite a lot of, resources. You must allocate enough resources to your IS server to be able to expect a better result, and also to decrease the time of the scanning, because sometimes I had a situation that a simple IS test took 72 hours just for a simple application. And this is super important to think about the performance, to think about the resources you want to allocate to your IS engine. Here is the second part. The second part just started. So, RASP. How many of you previously worked with a RASP solution? Just raise your hand. Cool. Yeah, but no worries. We just want to review the my experience. Maybe that would be helpful for you as well. So RASP, or runtime application self-protection. So it is actually, it's not a solution. It's not a I call it a function actually. So it's a helpful function for us to put it inside the application we want to release, we want to develop, to be able to battle against the threats, to battle against the exploitation in real time. So that's super important. And it also understands the logic of my application. So now it's covering some of those gaps which we actually reviewed earlier at this presentation. So it understands what's happening there, and also then it can detect what's going on. Okay, this is kind of exploit attempt, and the mitigation as well, all in real time. But yeah, I'm just gonna make it super simple for you by a very tangible example here. Also, I always try to make my presentation a little bit fun. Do you know this guy? Not the first one, that's definitely Lionel Messi. The guy behind Leo. So that's, I think, Yasin Chilko, if I spell it correctly. This guy is a very well-trained, world-class bodyguard. As you can see, he's not like a typical bodyguard. You see that you go for shopping, and you can see bodyguards, the front of the stores, they're standing there, and sometimes they say, welcome to the store. This guy, he doesn't talk. So what's the difference between these typical bodyguards and this guy? He is always with Leo. He's even inside the pitch. He's always checking the environment, looking for anyone gonna, the people jumping inside the pitch just to take a photo with Messi, or just taking a signature or something like that, or always thinking about Jimmy John's, and also any kind of threats. He's always thinking about the future. So it's not like those bodyguards for stores and shops. So he is an exceptional, a different kind of bodyguard. He's always ready for a threat. He's always ready for exploitation. He's always scanning the whole pitch, always scanning the environments, even if they're outside of the pitch. This guy is a real example of RASP, because RASP is also always thinking about the future, always scanning the environment, and always ready. And this guy actually mitigating a threat. That poor kid actually got eliminated by this guy. So, and the RASP as well. RASP is taking care of the application in real time and bringing the protection as well for real-time protection kind of activities. So yeah, RASP is something like this guy. And yeah, let's talk about the benefits, some benefits from my standpoint. So yeah, as I said, RASP brings real-time protection for you. So it's acting as a guardian, acting as a bodyguard. So within your application, and it's ready to catch the bad guys, not the bad guys themselves, but the activities, the exploits, and mitigate that one in real time. It's super flexible, so RASP solutions, depending on the tech stack you're using and depending on the RASP solution itself you want to use. So it is super flexible, so you can embed that within different kind of environments. I will tell you some of the examples, and also it's secure software development lifecycle friendly, and also DevSecOps, so you can add it as an additional process and within these phases, but keep in mind that this is not this solution is going to embed within your application. So, and it also receives updates, so manually and automatically, so you can update your RASP function within the new database, within the new signatures. So it really depends on the RASP and the application or the asset you want to put that function into. And also compliance friendly. Yes, that's compliance friendly because you can have different kind of logs, and also you can integrate it with your SOC as well. So you can send all of those logs into another place or aggregate all of those for further analysis or investigations. And also that would be also a plus for RASP function, which makes it capable of learning and understanding more, because you have more logs and then you can perform more investigation and improvement based on those logs. And also reporting, you can have different kind of reporting based on the compliance, based on the regulations you want, and also based on the incidents and the activities of your RASP function. Yeah, so now you're asking yourself that what is the difference between RASP and those solutions, SAST, DAST, IAST. So it actually protects applications in real time while working inside those applications. So it's not a third party, it's within the application. And also it automatically responds, no need for manual interaction in most of the cases, it really depends, I will tell you. And also, so SAST is good for pre-deployment, as I said, and it's also fit for source code analysis and doesn't offer you a real-time protection while RASP does. So, and also DAST is post-deployment solution, and also it's good for external testing as a part of security assessment, as a part of penetration testing, or as a part of your AppSec policies. And finally, SAST, DAST, and IAST, they're focusing on pre-deployment testing, identifying the security flaws and issues without the capability of responding in real time, catching those guys like what RASP and that bodyguard, they do. So a question for you, is this function, is this technology, is it proactive or reactive? So think about it. So to deploy as a simple steps, like if you want to deploy RASP, so the first part is thinking about the integration. So you must be able to integrate RASP within your application and runtime environment. And then we have continuous monitoring. So you must be able to continuously monitor the environment to look for any kind of technical issues. And also the RASP functions must be able to read the data flows as well, incoming and outbound traffics as well. So, and also if there is any internal activities, that must be included in that. So the third one is the real-time analysis, and within the real-time analysis, RASP is going to find and understand what's going on there. So what is this application, and understanding the logic of the asset as well. That would be helpful within the next steps, which is the attack detection. So within the attack detection, within that knowledge, or that knowledge can be a very good one after a while, and also it can be a baseline or something which came from the database or the patterns you put in. So it can identify the anomalies and the suspicious weird the activities within the application that might related to a real attack. And then we have immediate response. Yes, we can expect that one. So actions are taken automatically. Everything it can be automatically within the RASP function, and also it can be even a little bit more lighter. It can also always be alerting and generating logs and sending those to another place. So it's not always protection and mitigation. It can only be in a promiscuous kind of mode, you know, just learning and just alerting those things and sending those logs and activities to somewhere else. And also the last one is adaptation and learning, and all of these steps, they're helpful within this moment. So this moment RASP will start learning more about the application and training itself for better detection, better response, and having some improvements. And also it really depends on your strategies, and also you must be patient as well, because sometimes it takes a while to have that level of maturity within your RASP function. Here is a big picture of RASP, so just to make it simple for you guys. So it can be in control mode or even in monitor mode. Then I will discuss that one a little bit in this presentation. However, so you can see that we have a normal inputs from legitimate user, and also we have malicious inputs from outsiders, attackers, and some malicious entities. And in monitoring mode, it can be, you know, just learning and logging the activities, the interactions and other things. And also the main point here is the learning point. So the RASP will learn from the application itself, the whole application and all the activities happening there. So, and then within the monitor mode, while the RASP is still learning, also it can, as I said before, it can be integrated with your SOC, and also you can aggregate all of those logs and send them to another place for further analysis. And in control mode, there will be additional steps there, not only logging, but also mitigation in real time. You will have protection, so you can basically RASP can block a request and block a malicious threat. And it really depends on the policies and configuration. It can be based on IP address, it can be based on the requests, and it really depends on the tech stack and the protocols in place. And also it can detect that this request is not that malicious, and it can be can consider it as a normal one. It really depends on the technologies. So. However, so RASP is not about the, you know, specific kind of applications. So, you know, it can be embedded agents like within your IIS or Nginx. So you can have it as a plugin or server add-in, like you can have it like a mod security, and also non-web and standalone applications as well. So you can install a RASP as a local agent on your endpoints and workstations. And also you can have it as a background services, like a daemon, like a Windows background service, and mobile applications as well. So you can integrate RASP with iOS and Android. And also I will tell you some examples if you want to start working with RASP. And there is a possibility to integrate RASP with cloud natives, with Kubernetes, with Docker, and microservices. So that's a good news, that RASP is not only for, you know, web applications or standalone applications or executable files. Even you can embed it within the IoT-based framework, MBIoT, the IoT for the routines every day, so for smart home stuff. And also a little bit more technical, you can have a RASP for API gateway as well, just to check it out, what's happening there for the API gateway as a first level of, you know, interaction with the outsiders. So bunch of possibilities, different options, and also different deployments, different requirements, so, and different tech stacks. And for each of these, that's why I call RASP a function, a technology, you know. Some pre-deployment precautions. So that's what I actually wanted to highlight here, some of my experiences. So first of all, you must make sure that the RASP is compatible with your application and target asset. So make sure that the RASP you're going to choose, even the open source one, a free version of a RASP, or even if you buy a RASP solution, you must make sure that that RASP function is going to be compatible with your programming and tech stack, programming language, and the frameworks you're using. That's super important, because then you can save time, especially if you want to move with just for fun and profit, playing with open source and free RASPs. Because if you want to choose a commercial one, then the sales team and that company, they will guide you through the process. And definitely performance benchmarks. So be careful about choosing the RASP and also the resources you want to allocate within the server and the application is going to start the RASP. So, and always start different virtual machines, for example, or some isolated environment, to be able to actually have a comparison of the results, check the performance and the output of each of those machines. And that's super important. Always keep in mind. And also the last one is the operational integration. So just make sure that everything is at least possible and ease of use in terms of CI/CD pipelines. If you want to think about having RASP within your organization, and having some strategies within the deployment and integration, that would be super beneficial for you, because it costs time and money as well, and the human resource as well. Yeah. So I've discussed the different modes of RASP, but yeah, let's have a deeper look at the RASP modes. So you can have it as an active for protection and passive mode for monitoring. So these are two modes of RASP. So you can have it active or passive, and you can expect protection and monitoring. However, within the protection mode, you can expect monitoring as well. That's obvious. So you can have all of those logs, and the logs will generate it, and you can take advantage of logs as well. So for active mode, just note that the application will require resources, and the resource usage can be amplification there. So because you must be careful about it. So, and also it will be some overhead on your own application as well. So that it's better to discuss that deployment, that integration with your architecture as well. Or if you are the main developer, make sure that everything is fine and compatible with your apps as well regarding the performance and the resource usage. If you want to run the RASP within the active mode, so make sure that you can expect some latencies and performance impact for sure, and that's why you have always thinking about fine-tuning and improvement of your deployment. And also, once RASP learn more about your target and your assets, then it has more knowledge, and then the performance will be decreased, and the delay and latency, and the performance will increase in terms of detection and response. And within the active mode, benefits, we will have real-time detection and prevention together. And for passive mode, so it will be limited to, limited resources will be fair enough, because it will be acting in a passive mode, in promiscuous mode kind of deployment. Then it will only checking what's happening there. So the inbound traffic and outbound traffic, as well as the logs generated there. So then you can run it within a limited resource or limited budget. So you can expect lower latency if you want to compare it with the active deployment. And the log will be generated there. You can work on that, and it can be really beneficial for the learning part as well. So it's super important. And also, it really depends. Learning part and the log generation, it really depends on the type of RASP. So in commercial mode, sometimes there are some SaaS solutions the companies provide, and then you can forward some of those logs there, and it will be improvement by some kind of machine learning algorithms there to be able to improve your RASP deployment. However, in some local and free deployments, so it can be a little bit challenging for you. So let's talk about some of the techniques within the RASP. So basically, runtime application security platforms, so they use traffic analysis by acting as a kind of deep packet inspection or even signature-based detection. So they will be able to, reviewing and actually collecting the logs, collecting the data flows from the inbound and outbound, or both ingress and egress traffics. And also that's a vital information they need. And then we have the behavior analysis. The behavior analysis will be performed and monitoring against the application behavior and how the application deal with different components. It can be internal components, it can be external users, like how the RASP can find a legitimate user or a hacker or outsider. So it can be through the historical analysis and through the application baselines based on what you defined before. And then we have anomaly detection and or heuristic one. And this can be based on like some machine learning algorithms or predefined models. So you can put some predefined models as well if you work on a model based on the behavior of your application and the how RASP you expect to behave as well. And it is also helping you within detecting the abnormal activities. That's super important, because if you have a better learning process, if you have a better predefined models, then you can expect more better performance and more findings within the application and within your RASP. So then finally we have the signature analysis, which is obviously it is containing the known vulnerabilities, known payloads, and well-known attack patterns. So it's like what we can expect within those traditional tooling. So regarding the code analysis, so I have to say that so RASP functions, most of them, not all of them, they can even monitor the execution of code to detect any kind of suspicious or malicious operation with it within the execution that could harm the application. And also it can be through the bytecode analysis. And the memory analysis also, it will be monitoring the whole memory area and spaces to look for any kind of heap manipulation, modification, unauthorized access, buffer overflow, and these kind of activities. And you can expect to mitigate those buffer overflow vulnerabilities within your application. So if you have a C++ application, then RASP can be the best option for you to mitigate all of those. So, and implementation, what I did, so I had a phase of RASP solution. So I've compared different kind of RASPs so on the market. So first of all, for the POC phase, I went through some of the open source and free tools. And then I had that RASP solution in comparison within the commercial tools as well. And then I went through the integration. I was thinking that how I can deploy and how I can integrate the new technology and this new tooling within my current deployment. And also I was thinking that the configuration, so configuring that RASP and embedding inside the application without any headaches. And then I was into the monitoring and logging. So I was monitoring for instance, I had a monitoring session, so for 24 hours, even to 1 month of monitoring to detect if there is any kind of technical issue or flaw within the whole deployment, or even affecting my application routine. And then I will start optimization. After I made sure that everything is cool, everything is okay, then I started to improving my deployment. And also I've worked on baselines and I worked on predefined patterns, and I put all of those, and then I tested again, and I found that okay, this works, that it doesn't work. And I was thinking that if I can move forward with another solution or commercial one, and thinking about machine learning algorithms, even if you want. And in action, so I've said that regarding the integration, so think about the compatibility, have some kind of different assessment for the compatibility, as I said before, having a performance impact assessment. Just be careful that sometimes I forgot to do that, so but please document everything. That would be really helpful for other departments if you want to have it within your organization, if you are going within your own. So, but also documentation will be very, very beneficial. False positive and negative monitoring, that's one of the outcome of the monitoring section and monitoring phase. Within that phase, so you can easily find which one is false positive, which one is false negative. And then policy optimization and how you can handling the alerts, and also RASP. If you want to, you can put it there, shifting, and or even you can transfer the logs to somewhere else for better alert handling. And also, you can expect and document your expectation regarding the compliance and reporting. So it really depends. So you can easily move based on PCI DSS if you are in the financial sector, or even you can have OWASP as your baseline and kind of reporting. You know, you can easily set it up and configure the reporting based on the top 10, or even a little bit more about ASVS and a testing guide as your a Bible for the reporting. And some real world examples. But that's not limited to these, but yeah, just want to share some of those real world examples of RASP there. So there is a project called Free RASP. So it's free, and also it's community based. And also we have Open RASP as well. Then you can enjoy that one. And this is a little bit mature kind of RASP, but it's a little bit complicated in terms of integration. And also there is another one, Exploit Guard. I think this one has some built-in function that you must pay, if I'm not mistaken. And yeah, just a quick recap. Differences between RASP and IaaS. So definitely regarding the functionality, so IaaS for sure is a security testing tool, while RASP is a security prevention kind of tool, or even it can be a mitigation kind of tool if you want to have it in a different mode. For detection, so IaaS definitely detects security vulnerabilities and flaws within your application. However, RASP is going to detect the threats and attacks in real time. And for operation-wise, IaaS analyzes the application during the runtime, but RASP integrates within the application and also monitor the application within runtime. So, and also prevention in real time. So for the integration part, so IaaS typically used so within the testing phase or within some predefined environment and development phase as well, while RASP is integrated within the production application. So, and you can easily release your application on the market while you have a kind of function acting as a RASP inside that application, like a mobile app. So IaaS focuses on identifying the potential security vulnerabilities, security weaknesses, while RASP focuses on actively protecting your application in real time. And RASP versus WAF as well. So yeah, WAF is kind of primary security, almost, you know, the first layer of security as well. Like me as a outsider or user, I will definitely interacting with your WAF first, and then, but RASP is kind of last layer of security and last layer of defense. So you put it inside your application, and it will try to detect and mitigate the threats or exploits. Regarding the operation, WAF is mostly based on the HTTPS requests and responses. It will inspect the requests, while RASP alerts and block based on known and potential threats based on the application behavior, and perform inspection and behavior analysis. So attack handling, so basically WAF block and block threats and block exploitation attempts based on a database of rules or signatures, you know. Meanwhile, we have like next generation firewalls as well, but typically WAF is based on existing rules. However, RASP also you can expect to mitigate 0 days as well, because RASP has that knowledge of the normal operation of your application. Then it can easily detect the abnormal behavior. Also for the automation, so WAF is requiring a manual rule configuration sometimes, but also there are some ways to automate this one. However, RASP is you don't need to interact within any phases there, except once you want to improve or put or inject some baselines or signatures by yourself. And the security approach of WAF is reactive. It's based on some payloads and signatures, while RASP is proactive and comprehensive and handles unknown threats as well, because it has that knowledge. So a tangible example here as well, like if I want to say something about Log4j, so I would say that WAF is a better solution for Log4j because you can detect and mitigate a battle against Log4j within your perimeters. So in earlier stages, you can detect Log4j attempt, while even for sophisticated attack, for APTs, for a little bit more fancy attacks, RASP can be a best choice for you because it knows the knowledge of an understanding of how the application works and legitimate requests and legitimate responses and everything as a knowledge database, and then easily can detect the abnormal activities and such attack, or even it's really good solution for business logic kind of attack if you want to detect that and mitigate business logic attacks. So conclusion, it's definitely up to you. So I just wanted to share what happened within my experiments. So it's up to you if you want to choose RASP, if you want to say RASP is a good solution or not. But yeah, it was just sharing some of my experiences with you guys. And here is a list of the references, and also references for those fancy graphics. And the final word. So I'm not talking with you guys, the expert guys here, because I'm not in that level of the maturity or to be able to advise you guys. So, but yeah, for the youth and for the graduates or who wants to start the journey here in cybersecurity, please adhere to the ethics and always respect to the people who is, in the industry within years of experience or older than you in terms of technical, experience and technical. And also always share what you learned. That will be super beneficial for you as well. So sharing is caring, and also while you're sharing something, you will understand more. And while you understand more, you will understand that you know nothing and you have to try harder. And stay in touch so we can discuss more about this topic or any other topics as well. So I'm also geek like you guys. So this time, this is my first time here at BalCCon. It was super amazing conference so far. And also a big shout out and thanks to the organizer here and also all the other crews here working 24 hours a day. And also this was exceptional because I had my wife with myself as well. And that was super amazing for me. And thank you so much for the time. And I hope you enjoy the conference as well.
Thank you a lot. Do you guys have any questions? Okay, we have one here.
Hello, thank you for your presentation.
Yeah.
So I have a question. Is Falcon from CrowdStrike an example of RASP solution?
So you choose the best one. Yeah, actually there are quite a lot of commercial tools on the market that are working on RASP, but you must be careful that while you are choosing RASP. So sometimes you don't need to choose a RASP, If you are thinking about a sensitive application which is kind of vulnerable to some specific solution, some specific attacks, and you're looking for some specific solution to protect that. So you must consider your budget, you must consider the threats, and based on your objectives, which defined in your cybersecurity strategies, cybersecurity policies, yes, you can choose one of those commercial tools, but it really depends on your tech stack. If you want to protect your executable file, exe file, or if you want to protect your mobile application or web application. Sometimes for web application, it's not a good solution for now to choose a RASP because of the money. So money-wise, it's not a good solution. But for mobile application, I'm handling PII data, I'm handling thousands of transactions in a minute. Then I have to put something there to be able to detect and mitigate the sophisticated attacks.
Thank you.
And if you are not going to receive a blue screen as well.
Hi, thank you. So you compared RASP with SAST, IST, etc. But I'm under the impression that some of the features of RASP also are very similar to what is offered in cloud-native application protection platforms, as well as CM and SOAR stacks. So I would like to know, do they? And if they do, how do they complement one another?
Yeah, exactly. That's what I think I covered it in early slides in the presentations, that I call the RASP not a solution, so it's just a function. So you can even expect to have the similar functionalities within other deployments and within other components with your deployment. So you are thinking that I need something to detect or to monitor something, but you can get rid of those issues by deploying something else or by using other solutions. So you can think about that one. It's not only one option to install or deploy a RASP one. So because you can expect to have the similar functionalities within other deployments or within other tooling. You're right, yeah.
Okay, thank you. Do we have any other questions? I think we don't. Thank you a lot.
Thank you so much.